In this tutorial, what we're going to do is take a look at how to make the circuit for the digital die. The way that works is we're going to have a whole bunch of LEDs. They're going to represent the outputs, if you like, and we're going to be doing our processing using a thing called a Genie chip, which we'll learn a bit about as we move through this project. And for the input, that's going to be basically a person who's going to push down a button, which will allow us to roll different numbers on the die. So the first thing we should probably do is get some power for the circuit, and I think for this we'll use a 9-volt battery because they're really commonplace and easy to get hold of. What we'll also need to do as well is bear in mind that the Genie chip itself doesn't really like to get more than about 5 volts flowing through it. So at the moment, if we connected this 9-volt feed straight to it, then it would blow the chip up. It would never work. But we can use a thing called a voltage regulator, which is just here, and we can pop that in the circuit. And basically that will take in whatever voltage you like, so in this particular case about 9 volts, and it'll pump out 5 volts, which is perfect for a Genie chip. You also need to give it what's called a reference voltage, which will connect to the negative end of the battery, so it knows what 0 volts or what negative looks a bit like. Next thing I suppose we'll probably better do is handle our processing. Processing is going to be done with a Genie chip, which is found in this microcontroller section here of the gallery. So I'm going to take one of those Genie CO8 chips that I've got, and I'm going to pop that in here. The more we think about the way this particular project works, what we come to realise is that there's only one input, and at the moment the way the Genie chip is drawn is it shows you its inputs on the left and its outputs on the right. As I said, we only need one input. We're actually going to need, as we'll talk about a bit later on, we're actually going to need 4 outputs for this particular project. And we can actually reconfigure our Genie chip by right-clicking on it and going to Program and Program Settings. We can reconfigure the Genie CO8 to have just one input, which gives us 4 outputs. So that's something else we need to set up. There they are now, look. The Genie chip itself will need some power, so I'm going to do that by connecting the power end of the Genie chip. You see if I hover my mouse just here, it says pin 1 power, and it'll also need a connection to 0 volts to complete its own circuit or ground, which I'm going to connect like so. What else should I do? Before I do that, I'm just going to take this here and leave a bit more space just here, because in a minute I'm going to need to connect my switch up for my input. Let's do that now actually. So for the button switch, what we do is we go in the shopping cart and there's input components, the switches. What we want is a push to make switch. Okay, I mean we could do it with the other one, but it's just easier. I'm doing it this way, I think. And the way that we set this up is we have it so that the top of the switch has got 5 volts, and when we push the button, that completes that circuit and allows 5 volts to flow into the input here on the chip. Okay, that's how the switch works. One of the things that we kind of find when we actually manufacture this in real life, though, is that when we're not pushing the switch, this piece of wire effectively isn't here, there's nothing there, and this input is left what's called floating. It's where the circuit doesn't really know if it's been pushed or if it's not been pushed. It gets a bit confused. And so what we need to do is to help that a little bit along by using a thing called a pull-down resistor, which is this thing just here, which I connect to the bottom of the switch, and I connect to the 0 volts rail, the negative end of the battery. If I bring this down, you can kind of see that visually more easily. And we use a 10k resistor for that. The purpose of this resistor is just purely so that we say to the circuit, if no one's pushing this button, then you need to have 0, nothing whatsoever flowing into that input just there. It pulls it down, as it's called. Okay. So if we didn't have that and we actually manufactured the circuit, you'd end up seeing it go on off all the time. Next thing to do, I'm just going to delete some of these labels as I go along as well, just to sort of declutter a bit. You don't have to delete the labels, I just kind of like to, because it gives my circuit a slightly cleaner look. When we come to design and manufacture the PCB down the line as well, it's quite beneficial to do that there as well. Okay, so that's that. Let's talk at the outputs. The outputs are going to be a bunch of LEDs, and the way I figured would be a good way to do this would be with some LEDs set up representing the individual points on a die. So yeah, I basically need to get the other LEDs in. Now I suppose in order to do this I'll need a single LED by itself so that I can represent the number 1. And what I'll then need is I'll need a pair of LEDs so I can get 2. I'll need probably another pair because 2 and 2 together gives me 4. If I've got those 2 pairs of LEDs and a single one by itself, that gives me 5. And then finally to get 6 I'd need a pair, and a pair. You see what I mean? So let's try and build that in now. So one of the other things I'll need to do as well is whenever you use an LED, if you think about the amount of power that's flowing out, I've got 5 volts coming to about here. This uses maybe 2 volts, so that leaves me maybe less actually, about like 1.5. So actually by the time I get to this output, I've still got sort of 3.5 volts, which is probably a bit more than this LED really is quite used to taking. So there's a risk it'll blow the LED up. So I can slow down the amount of current coming out by adding a resistor just here. I'm just sort of spin that around and pop that in just here. And I reckon for this particular purpose, probably a 220 ohm resistor, I reckon that should do the job quite nicely. So I'm going to draw a line from there to there. I can then connect up my LEDs. I'm just going to copy and paste these LEDs a whole bunch of times. So I need a pair, and I need a single one by itself. I'll sort of stick that a bit lower down, maybe just here. I need another pair, so I'm going to try and pop that about here somewhere, like that. And I need another pair as well, and I'm going to stick those just here, like so. Need some more of these resistors as well, so I'm just going to again copy and paste a bunch of those, stick those right next to the output so I don't forget them, and connect them up like this. There we are. I can then start the very serious business of connecting up the resistors to the LEDs. So you can see that this resistor here, this output, is connected to 2 LEDs, and after that it can go down to 0 volts, like that. That also takes us to 0 volts. I did my single one next, so probably slide that out one more actually. There we go. That's the single one done. Jiggle that along a bit because I might struggle for space otherwise. Next one's here, so again let's lift that up slightly and pop that there. There's one next to my double one. And I've got another double just here. And I'll pop those there like that. Looking good. I then just need to get all these to 0 volts. You shoot straight down. And you can shoot straight down. And you can shoot straight down as well. Looking good. So that's pretty much actually my circuit diagram. I've got to leave very messy labels all of a sudden. Look, you might want to come in here and clear all these labels out. Be careful you don't click on the resistor itself by mistake. Oh, like I just did that. Looking good. And all these Ds as well, they can go. Okay, so anyway, leave it at that. So that's my circuit diagram for the digital die. What I'll need to do in the next tutorial now is to actually put together a test program so we can actually make sure that that works, and then we can get on to designing the PCB. So I'll see you then.